Joe, is your team ready for the software regression test of the next release? The quality is very critical for our customers.
Yes, but the timing is very tight. There are plenty of tests to be done and they only have a day for the regression test.
Okay. By the way, Paul, we have about 10 development boards returning from our customers. We need to check them for defects.
Oh. Our hardware engineers need to test the boards manually. They won't be happy to test 10 of them.
Looks like there is a lot of testing to be done by both software and hardware teams. Recently, one of my colleagues mentioned about a product called EZPy. This is a PC application GUI that provides a platform to automate the testing of the electronic boards. He says it is affordable and user-friendly.
Sounds interesting.
Yes. With EZPy platform, the PC communicates with the test and measurement devices and electronic boards to sequence and time the testing activities.
Does it generate test reports?
Yes, it evaluates the tests based on the criteria provided and generates test reports. EZPy has a free version with limited features, so we don't pay anything to try it out.
This may be useful for our warranty testing also.
Great, let us try it. This can reduce our testing efforts significantly.
Hi, I'm Srikanth. For your development, you may be using a lot of devices that can be connected to the PC. For example, electronic boards, devices like oscilloscopes, USB oscilloscopes, signal generators, USB to CAN, USB relays, internet, and many more. And you may want to control or communicate with these devices and sequence certain actions to achieve some kind of automation. EZPy is an easy and affordable solution to achieve this goal. Let us see how EZPy works. Take a simple example where you need to automate the testing of a PWM output of an Arduino board using an oscilloscope. Let us see how this can be done. So you have the PC, Arduino board, and an oscilloscope with all the connections. Now set up EZPy software in the PC. Add the device driver for Arduino board. EZPy controls and communicates with the Arduino board using this device driver. Similarly, add the device driver for the oscilloscope. Next is the definition of evaluation types. For example, range bound check for duty cycle of the PWM. Or there may be other eval types used in the tests. Next is actual sequencing and timing of the activities for automation. This is done in the test case definitions. In the following slides, we will be explaining some of these blocks more in detail. Let us see how the GUI looks. Here is a sample screenshot for the example mentioned earlier. This is the test case tree window. As you can see, multiple tests can be defined here. For example, the first test is for period 100 millisecond, the second test for period 120 millisecond, and so on. This is the actions or devices window. For simplicity, let's call it as actions window. All the device drivers used in the project need to be added here. In this case, the oscilloscope and the Arduino board are already added. This is the description window. It provides a text field for the user to describe the test. This is the scheduler window. The timing and sequencing of the actions and variables are done here. For period 100 millisecond test, duty cycles at 20%, 40%, 60%, and 80% are tested. This is the evaluation window. For each test, we need to select appropriate evaluation type or types and fill in the related parameters so that EZPy can evaluate the results of the test. In this particular case, we only use the eval type for range bound check. This is the plot window where the relevant variables are plotted for easy visualization. Now, let us see it in action. Here is a snippet from the actual execution of the period 100 millisecond test. The red signal is the commanded duty cycle from the Arduino. The blue signal is the measured duty cycle from the oscilloscope. As you can see, the measured duty cycle closely tracks the commanded duty cycle. At the end of the test, the measured duty cycle values are checked for the upper and lower limits. In this case, the duty cycle values are all within limits and hence the test case is a pass. What if you need to replace the oscilloscope with the signal generator? It is simple. Just replace the device driver and configure the test as needed. In fact, you don't necessarily need to remove the oscilloscope and its device driver. You can as well leave it in the action window and never use it in the test. Basically, any device that can be connected with a PC can be easily interfaced with EZPy. So, EZPy is designed for easy plug and play of devices. In the last several slides, we talked about the device drivers. These are actually files in Python programming language with well-defined structure. You might be wondering where these action files are coming from. Here are the possibilities. For the very common devices, the action files are available for free download from our website. Second, the users familiar with Python programming and device control can develop the files on their own. The third option is to get it developed by Texar for a fee. Eval types are again defined in Python, and they also have a well-defined structure. So where do they come from? The common eval types are bundled along with the EZPy download, so they are available for users. Second, the users familiar with Python programming language can develop the eval types on their own. The third option is to get it developed by Texar for a fee. So why Python programming language? Python is a high-level programming language suitable for beginners because of readability and simple syntax. Python code is usually very concise compared to other languages. It is also one of the fastest growing languages. It is object-oriented. It has robust development tools like PyCharm, IPython, etc. There is a large supportive community. There are plenty of free Python libraries. For example, math. This is the basic math library. NumPy. This is a library that adds support for the manipulation of large multidimensional arrays and matrices. It also includes a large collection of high-level mathematical functions. NumPy serves as the backbone for a number of other numerical libraries. SciPy. This is a large library of scientific tools. PyVisa. This is a Python package that enables you to control all kinds of measurement devices independently of the PC interface. PIL, or Python Imaging Library. This is a free library for the Python programming language that adds support for opening, manipulating, and saving many different image file formats. It even has libraries for symbolic computation, data analytics, visualization, video processing, etc. etc. So, what about the licensing options? First, free version. This is available in our website for free download. However, the features are limited in the free version. Second, paid version. This is the commercial version with all the features. Third, complimentary version. In rare cases, we also issue a free license based on mutual benefit. Example, for a user who agrees to pilot the testing of a new device. EZPy is a visual and intuitive test automation platform. Users have the freedom to define the action files. Users have the freedom to define eval type files. Python packages can be easily integrated. Test reports are generated, so there is no additional effort for documentation. Hope you enjoyed this video. If you like to experiment with EZPy, please download the free version from www.texarsys.com. For support, please contact us at support@texarsys.com. We love to hear back from you. Thank you. Have a great day.